Hello everyone. So, in this lecture today we are going to talk about a very interesting idea, that is choosing axis. Now, you may be surprised and you may say, sir, there is no topic like that in any physics book. So, I will be a little bit unconventional during this first series of lectures, where I will be taking topics which are going to help you solve lots and lots of problems and which have far reaching effect on your overall problem solving and thinking skills. And some of these things are quite obvious also, but maybe if you know the obvious and the logic behind obvious, sometimes it helps strengthen your concepts. So, here we are going to talk about choosing axis. What is it that I am talking about when I say choosing axis? So, first introduction of a physics student about axis comes when he encounters problems of projectile motion, and specifically in projectile motion when you come across problems of inclined plane. So, in other words, you may say that I will be talking about projectile on inclined plane. Inclined plane projectile. Now, is it limited, the concept choosing axis, only to inclined plane projectile? Answer is no. It is the first time that you encounter this idea is when you study projectile on an inclined plane. But this is not the last time, this is just first time. In fact, there have been great many problems which you may encounter when you study further in class 12th, magnetism and these type of problems where there are complicated forces, where choosing correct axis becomes critical. Not only that, these days JEE has started giving questions where they show you a problem in a 3D scenario, and when they are showing it in 3D scenario, the problem you may encounter is which axis needs to be eliminated while drawing on the board, because board is 2D. For me it is board, for you it is paper. So, which axis has to be excluded, which would help you solving problem. So, we are going to talk about things which people generally leave on your own intelligence to figure out, and I am going to try to help that. Maybe you, if you are a very intelligent student, you would have figured it out already, but even then if you know, yeah, what you are figuring out is correct, it helps make concepts strong. And those who have not figured it out yet, definitely it will help you that what does it mean choosing axis. So, the point here is this, that any given problem, let us start with projectile, that there is a ground and we say we are projecting something with u velocity. The natural choice to draw axis to solve this simple 2D problem, you must have seen that, is an x-axis like this, a y-axis like this. X-axis along ground, y-axis perpendicular to the ground. This color may not be easily visible, not even this. Let's just stick with white and yellow probably. All right. So, I'll just drop the axis again, so there is no confusion. This as x and this as y. right? Now what happens next? Why do we choose this axis? Why don't we choose something else as an axis? Maybe somebody may come and say, I am choosing this as axis. You may say it is wrong. The point is, it is not like that one axis is wrong and other is correct. It is just that by choosing correct axis, solution to problems becomes quite fast. So why not choosing this axis? This is y axis. You may say, sir, if I choose this as x and y, then I have to take component of gravity. If I choose this as x and y. Okay, I would say right. Whereas I choose this as x and y, there is no component of gravity. Yeah, let me show it to you again. That if we have chosen for this particular problem, where we are projecting like this, this as x and y, we have to take components of gravity, which doesn't sound good. Right? Whereas if we choose this as x and y, we are not going to take components of gravity. Yeah, sounds good. But the question that comes is this: what happens when we are choosing a scenario where we are projecting on an inclined plane? Then people will come and tell me, okay, here this axis is good. So you may form a rule that, okay, we must take axis along the ground. Is that the correct reason? Or is there something more? I hope you are curious enough now to delve into this, that why and how we choose axis. Because if it is simply that reason that it must be taken along ground, then there was nothing to be discussed. There must be something more. So let's go into this. Now when we took this as x-axis and y-axis, according to me, what it simplified was this: finding time. Because when it lends, finding time becomes very easy, because lending means the y coordinate itself is 0. Your displacement in y is, you are able to pinpoint that lending means y coordinate is 0. Right? And similarly here also, the lending itself, the time when it lends, for this particular axis, you can say y coordinate is 0. So there is an ease to problem solving when you have chosen correct axis to find time. Here we can find time very easily. Initial velocity in y was u sine theta. Acceleration in y is minus g. And we just put it here. So 0 is equal to u sine theta into t minus gt square by 2. Right? Solve it and you will find value of time. It comes out to be 2u sine theta by g, which in projectile motion many people remember as a formula also. On the other hand, if you do this, there is one extra step. The extra step is to take component of gravity. which in y direction is minus g cos theta. So here, what do we get? Displacement in y 0. Initial velocity in y is u sine theta minus phi. And I think I committed a mistake here by writing theta. It should have been phi. All right. So acceleration along y becomes minus g cos phi. Again, we put it in the equation, s is equal to ut plus half a d square. Solve it and we get value of t. I'll put it somewhere here. So t becomes equal to 2u sine theta minus phi upon g cos phi. Right? So yeah, it works out fine. Let's go one step ahead. We want to find out how far it goes along the plane, which is generally known as range. Again, for this problem, in x-axis, excisional x is 0, right? Velocity along x is very simple, u cos theta, and time taken is here. So we can write range as u cos theta into time. And we get the standard formula u square sine 2 theta by g. Seems perfect. But when we do it for here, there is a small thing that we have to remember. There is a component along x also. Ax is minus g sine phi. Ux is u cos theta minus phi. So displacement in x becomes u cos theta minus phi into t minus g sine phi t square by 2. And then you keep the value of t here and keep on doing the calculation and you will get the formula for range. This is generally a standard method that students have seen using. Would you like to learn a method which is much faster than this? If we free ourselves from this restriction that there must be this x and this y while solving problem on inclined plane, because there is no law of physics which says it should be like that. Yes, this x and this y is very good for finding this time when it will land, but there may be some other axis which may help us solving this problem faster. So let's try that. You can also try. This is the incline phi angle. This is a projectile at an angle theta from horizontal. And we want to find out how far along the plane it traveled. Let's call it r. Okay, we want to find out this value of r. Now please understand, it will land here at time t as you already calculated. Let me put the value, 2u sine theta minus phi upon g cos theta. Right? Now, once we are through with this, we have got range, we have got velocity, we have got time. There is a faster way to solve this problem. If I say that this is my x and this is my y. Please understand, for finding time, this axis was good because we were able to point out that landing means y coordinate is 0. But once we have found time, the problem we are facing in that coordinate is we are dealing with a square coordinate relationship. T ka, we have to put square of t here, which would be troublesome. Right? What to do? There is another way. If I have taken this as x-axis, in this x, acceleration is 0 in this particular x, right? And initial velocity is u cos theta. All right? So, x coordinate, the projectile is traveling like that, but its x coordinate this x coordinate is varying simply as u cos theta into t. So at the moment when it lands here, it's this particular x coordinate would be equal to, let's call it x1, would be equal to u cos theta into the time that we've already found, 2u sine theta minus phi upon g cos phi. But you would say, sir, what is the use of this x1? We needed to find r. Look closely. This is r, this is phi, and this is x, right? So r cos phi must be equal to x1. Can you see that now? So see how easy now it is to write range here. Range would be x1 by cos phi. So it becomes 2u square sine theta minus phi cos theta by g cos square phi. That's it. This is the range. Can you see speed? So what I am saying is this, that we do not decide before we start solving problem that okay, if this is problem on inclined plane, this must be your axis. No. For finding time, this is good axis. But probably this is not so good axis if we are trying to find distance traveled along incline, because there you are facing this particular thing, then you have quadratic, then you have to solve it. It would take 2 or 3 extra mathematical steps, which may be critical if you have to solve a question in 3 minutes in JEE. Whereas if I find time using a different axis and solve it for this particular x, but obviously by trigonometry, we can connect the range to this particular x-axis and we can find range much faster in a more efficient way. So this is something that you will encounter throughout mechanics and as well as wherever motion is involved in physics, that choosing correct axis may help you solve problems much faster than just magnifying that okay, this axis is good and this is the axis for this particular problem. Let me take few more problems which would be little bit from Newton's law side, where choosing axis was important. For example, I'll start with a very simple problem, that if you put a block on an incline, right, and these are the forces acting, normal and mg. Generally we do this, we take these as our axis and we take components of mg, right. The question may come to your mind, if you think that what about taking this as x and y, why we don't do this? Nobody asks this because everybody just remembers this. For the very simple reason, because this is a particular direction where we are sure about one thing, to remain in contact, here acceleration is 0 if it is sliding down the incline. So we know acceleration beforehand in this direction, that's why we are choosing this as an x. And there are problems in circular motion chapter. If you have studied circular motion already, I'm assuming that, where they say we are dropping it and it is moving like this, mass connected with a thread. Then just next to it you may have a problem of something known as conical pendulum, where particle is going like this, angle is theta. This is called simple pendulum, this is conical pendulum. Now if you want to magnify, you can magnify, you can just do the ratta, that in this problem and in this problem, having exactly same free body diagram, I have magnified, I have ratta, that this should be the axis, and in this is the axis. There must be some reasoning behind it. Reasoning is very simple. Because it is a circular motion scenario, we know the direction and the magnitude of centripetal acceleration. In this direction, acceleration is known. In this direction, acceleration is known because the plane of circle is horizontal. So this is the direction in which we can conclude about the motion, that there is going to be acceleration in this direction. So by knowledge of that acceleration, we are able to choose correct axis. But I'll go back to projectile only, and let's take one or two problems. So I hope you understand that choice of axis should be done carefully, thinking about it, that is this axis going to help me solving problem faster, rather than just doing the ratta that, or magnifying it, that this is the good axis, this is the good axis, this is the problem to, in this problem solve like this, in this problem solve like this. Don't do this. Understand the reasoning that why we are choosing which axis. If you remember the reason, you will not get confused later on when you may have to change your axis. For example, I'll take a problem from projectile motion. Just a minute. Sure. Here we go. Again, projectile inclined plane, phi angle. We are projecting a particle with horizontal angle theta, u velocity. This particle flies and strikes the incline horizontally. It strikes the incline horizontally. So, find relationship between theta and phi if projectile is striking the incline horizontally. I would advise you to try it. Pause the video here, try it for a minute and see where you get it. So now you see, this problem may seem suitable for you, that okay, I must take this axis and striking horizontally means it is striking some at angle and solve it like that. But when I hear it striking is horizontally, something comes to the mind, that if striking horizontally, then essentially it is at the highest point if we consider horizontal and vertical as our x and y, not the incline as our x and y. There is no restriction. Please understand that if there is an inclined plane, I must take this as x and y. You can see in my previous solution where I found range, I changed the x and y to get to the solution faster. Similarly, there is no restriction, I must take the purple thing. I can take yellow x and y also. And yellow x and y would be really helpful in solving problem. Why? Because in yellow x and y, this is maximum height and this distance is range by 2. Because particle reaches at maximum height in this particular scenario when it is at range by 2. Because the time taken to go up and time taken to come down is equal. So, the distance it travels is exactly half of the total horizontal range. And if we agree with that, this is angle phi. Can we find r and h? This should be trivial. The maximum height, when it achieves its y component and velocity becomes 0. Uy was, according to this new one, u sin theta. Ay was minus g. We can solve it for vy square is equal to uy square. So if we put that, 0 is equal to uy square, u square sin square theta minus 2gh. So we have got value of h, which is u square sin square theta by 2g. Right? And what about r by 2? Range we found out just here. You can check. Alright. So r by 2, u square 2 sin theta cos theta. So this is what we have, and just need to divide them, because you can see very easily that 10 phi would be equal to h by r by 2. So you just put the value u square sin square theta by 2g into u square sin theta cos theta upon g. This is r by 2 here. Okay. This was r by 2. So let's move it a little bit. Okay. So tan phi becomes equal to tan theta by, see. So you can say, sir, I have solved it faster by other method or whatever, or I have solved it by different method. That's okay. All I am saying is, just looking at incline does not mean that you must take your axis along incline. Even taking this axis is helping us here solving problem faster than taking it along incline. That is my point. That is my very limited point. I'm not saying that you must take this or that. All I'm saying is, when you choose axis properly, you would be able to attempt problems in a better way, because sometimes you may choose axis which may take lot of time just because you didn't look into the problem before starting, that maybe some other axis can give me a faster solution. So this is my limited point. I'm not saying that you should not remember axis. Okay, you remember this is a good axis in this particular problem, but if you keep your mind open, you will have option to choose and solve for better axis. So this is the limited point. Let's try and let's just recap once where we begin. So we begin with that choosing axis is essentially a problem that you will encounter not only in projectile. Projectile is the first place where this may come to your mind, right? This is a problem, but there generally people don't pay attention. What they do is they just mugify that for horizontal this is axis and for incline this is axis, where I've already shown it to you that by shifting axis in incline, even in incline, for finding time a different axis and for finding range different axis, we are able to solve problem in a better way. And not only in projectile, I've shown it to you in other questions here. You can see this solution was faster, that even in Newton's law, there is a reasoning behind choosing axis each time, every time, because when you have to resolve forces, you would like to know acceleration as much as possible. So obviously in this case, we know if it is in contact with incline, all right, sliding down the incline, then acceleration must be 0 perpendicular to the incline. That's why we choose the axis. That's why we take component of mg, not of normal. You may say, why I am not taking components of normal? Because I am accustomed to this xy. Because that will not help you problem solving, because then its acceleration is this direction 0. It is accelerating in, oops, it is accelerating like this. Now you have to take component of acceleration. Would it be wrong? No, it would not be wrong. It would just take little bit time more. All right, but this little time is important in problem solving in JEE. Now in this it would become really difficult if you start taking wrong axis, because in circular motion centripetal accelerations are generally easily known and other components are generally difficult. So here it becomes of paramount importance that we know axis in this particular direction. So let's resolve forces. Just look at this problem, same FBD, but here you resolve forces along the string, perpendicular to the string, and in this particular problem you resolve forces in horizontal and vertical direction. So that's a big difference. So I hope you understand this, and we took a problem where we chose for an incline horizontal vertical axis and we solve problem like that. So next time when you draw this line, stop and think, is this the best I can do, or is there a better axis available? Most of the time your instincts will be correct, but one day in one problem in JEE, you're giving this much thought that maybe some other axis is better, may help you solve that problem and leaving that problem. Yeah, this is also happened in JEE. They gave a question way back in 2000s where if you choose correct axis, solution was like this, and if you choose wrong axis, the mathematical equations that were coming were probably almost impossible to solve. So that much critical it may become if you choose wrong axis. Thank you.